Hello folks, I apologize. I think I was about to show you, I was showing you how the trough was more negatively tilted in the old run than the new run. You can kind of see here, like, look at this here. This is your trough coming in from the west. This is your initial wave out here. This is your initial wave that formed the initial area of low pressure. This trough formed a surface area of low pressure. Again, I'm assuming it's surface pressure. And you can see how it's kind of neutrally tilted rather than negative. You can see these isobars are pointing basically straight down. This isobar does point to the left, which could suggest some backflow in here, but then as this comes east and combines with this piece of energy, that tilt is not going to be negative anymore. If you look at the old run here, you could see here that it looked just a little bit more negative, and it kind of looks like it's closer. So this is the other thing. This trough looks like it's a little bit closer, but in the new run, it looks like it's a little bit behind the initial wave. So what worries me there is that this shielded precipitation associated with this trough, if this is going to combine with the initial wave a little bit later than previously thought, maybe that piece of precipitation, that precipitation shield might come a little bit further north into central New Jersey, just south of Long Island in New York City. I would be worried about the south shore of Long Island in that respect, if the trough doesn't combine as quick. You know, I lost my train of thought, I'm sorry. You might get additional accumulations if the shielded precipitation associated with this comes further north. And what's going to happen is when these two pieces of energy consolidate, number one, instead of having two areas of low pressure, one along the coast, one out here, you're going to get one main area of low pressure. This low is going to start to close off, and it's going to absorb all of this energy into it. So as soon as this western trough, the trough from the west, combines with the initial wave here of low pressure, what will happen is your precipitation shield that was associated with this will just shift east, like immediately, and combine with the shielded precipitation out here, and you would get one shield of much heavier precipitation. So I am going to show you that, but again, just notice as we go along here that your low does start to close off, but again, in the new run, further east, I would say, see it's down here actually, and actually it closes off earlier in the new run because in the old run. In the new run, the trough comes in a little bit later, and so it hasn't really started to close off yet. So that keeps the precipitation out here. When it closes off, it's going to be further to the east. So you see this here. If you look at the old run, it's just a little bit further west, not by much, but just a little bit. See the vorticity staying off now? Okay, so that's the European model, and this is your trough coming in, starting to become a closed area of low pressure. Okay, here we go. This is your precipitation map. Let's just come back here. This is where we are right now, basically. This is the area of precipitation associated with your trough coming in, if you just want to look at that again. So this area of precipitation is associated with this trough here. Okay? And then all of this to your left is associated with this wave here. Doesn't really look too potent, but trust me, it is. So the first area was associated with this trough, which is a little bit negatively tilted out here, but you know, I just don't think it has the right tilt to bring this thing to the north, the initial wave out here. So that's one of the problems. But going back to your precipitation map, so I'm concerned about how far north does this get. Okay, that's what I'm concerned about, because if the trough comes in, combines with the initial wave later, this has room to come just a little bit farther north and bring heavier snows, possibly across the south shore of Long Island and the extreme eastern coast of central New Jersey and those areas there. That's what I'm worried about. But as you go along here, you can see you still have this area of precipitation associated with your trough again, back in here. This trough right over here. This is your trough and initial wave. So this trough is associated with this area and the initial wave with that area, but you can see they're starting to come together. So then what happens is they consolidate, and watch, this just shifts to the east. You think, oh, isn't this heavy precipitation just going to come north into New York City and Long Island? No, it does not. It shifts east. See that? So now this whole thing has come together. Now, let's say that didn't happen quick enough. Then you would have heavier snows coming back into Long Island and New York City. But, you know, the models aren't really showing that. Although the European, since they are combining later than earlier model runs, the European brings in the 2 to 3 inch line across central Long Island, which wasn't there before. So that's new. But now you can see you have, you know, Twin Forks getting battered by some moderate to heavy snow. Cape Cod, you're just getting screwed with this. Coming back into Rhode Island and other areas of southeastern Massachusetts, you have some moderate to heavy snow as well. Next run, Cape Cod, you're getting slammed, and then it's starting to come into down East Maine. And then notice how the coast of southeastern New Hampshire and southeastern Maine and back into northeastern coast of Massachusetts, you're getting spared from the heavy precipitation since the low is closing out further east. Okay? And then again down East Maine and then up into Canada, you are screwed with this. You are getting a big snowstorm. Okay? Now the next thing I want to look at is winds. So take a look at this. So this is 1 a.m. on Wednesday. So take a look at all the wind energy. This is the European associated with all of this. The wind energy associated with your main storm here. This is a lot of wind energy. The purples are 40 to 50 mile per hour sustained winds. Sustained. And then your 35 in here is, your red is 35 to 40 mile per hour sustained winds. And then in the center here, that's even greater. You know? Actually, no, I'm sorry, that would be less because that's the center of the storm. So you have stronger winds on the outskirts of the storm. So then as you go to 7 a.m., now you have orange, which is 30 to 35 mile per hour sustained coming into eastern and central Long Island. You got 20 to 25 mile per hour sustained coming across all of Long Island and coming into New York City. And along the coast of New Jersey, Maryland, and Delaware here, you got 20 to 30 mile per hour sustained. Gusts up to 40 to 45. Okay? By 7 a.m. Wednesday, you have 40 to 45 sustained coming into Cape Cod. Gusts up to 65 or 70 miles per hour, I would say, would be possible. Going back into southeastern Massachusetts a little further, I would go with 25 to 35 sustained. Gusts up to 50 or 55. Southeastern Connecticut and Rhode Island, 25 to 35 mile per hour sustained, gusts up to 45 or 50. Okay, this is at 7 a.m. Now, when you go to 1 p.m., you have 40 to 50 sustained coming into eastern Long Island, gusts up to 60. Cape Cod, 50 mile per hour sustained, gusts 70 to 75. Maybe even stronger, I would say. Hurricane force in Cape Cod here. Okay? And again, central Long Island, 25 to 35. Gusts up to 45 or 50. Cape Cod again, still 50 mile per hour sustained. Gusts up to 70. This is Wednesday evening. It'll probably start to die down by then across these areas as the storm moves out. And then down East Maine, you're going to have to watch for the same amount of wind there. And then this wind will kind of move out by the end of Wednesday night. Okay, see it's just starting to move out. There it goes. And there it goes. Okay? So that's your wind. Alright. I will very quickly, let's look at the weather map here. This is your radar. I want to show you the heavier snow that's associated with your trough. Your main storm is out here over the sea. Well, actually, this is your surface low here, I think. Then your main storm is all the way out here. Now, these areas of snow here are associated with the western trough coming through as it's about to combine with the main initial wave piece of energy. Now, what you're going to have is you have heavier snow working in across southern New Jersey, Dover, you're in it, southeastern Delaware, southeastern Maryland, into the eastern coast of Virginia. This band here, I think you could pick up an additional 1 to 3 or 2 to 4 inches in some locations. And for total accumulation, I think along the eastern coast here you could see up to 3 to 6 total. Now again, all of this is going to shift east when the pieces of energy consolidate, so that's something that needs to be watched. We want to see how far north does this heavier snow get. That's what we're concerned about. Alright, so there's that. And very quickly, actually, you know what? Let's just do this very quickly. Oh, I want to try to keep this to one video, but I don't think I'm going to be able to. I want to show